ต่อไปนะคะจะเป็นในส่วนของการบรรยายในหัวข้อซิมมาตอนกับเทคโนโลยี 3D Printing ค่ะโดยมิสเตอร์โคบี้ โรเซนวอเซอร์ ไวท์เพรสิดเนนต์ซิมมาตอนค่ะขอเสียงปรบมือต้อนรับด้วยนะคะ
My Thai language is Hasip Hasip, so I prefer to do English with your permission. So welcome to the next generation version E12 launching with Cimatron and MYGROWTECH, and thank you for coming. I welcome everybody who is here, and thank you for supporting Cimatron. Anybody is translating, by the way? No? All right. English. So, my name is Kobi Rosenwasser. I'm the Vice President of the Cimatron Group. You might have heard the latest news. We announced about 3 weeks ago, Cimatron is making an acquisition by 3D Systems, the leading 3D printer company. So this presentation that I prepared today is quite a long time now because Cimatron is looking at 3D printing for a couple of years now, but now I guess it's much more relevant. So I would like to go over 3D printing, what is 3D printing in general, plastic 3D printing, metal 3D printing, some hybrids, and how is software coming with 3D printing. Little bit more focus on the tooling industry, 3D printing in the tooling industry, and last but not least, what Cimatron is preparing for 3D printing. So, if we look at 3D printing, we are actually printing layers. You've probably seen that. This is very, the highlight of manufacturing these days. Everybody is wondering if it's going to take over manufacturing, conventional manufacturing, or just be an add-on. But as you can see, we are printing a 3D solid model. At the end, we clean the rest of the part. This is one way, and we get a solid model out and ready. So, plastic. There are few common ways, but two leading technologies. One of them called FDM, fused deposition modeling, where we actually deposit layers. We're actually using what you are very familiar is like the hot glue gun. And the way to do it is actually we deposit layer after layer. So we have a material, a spool of material. We heat the material, and when it becomes liquid, we actually deposit a layer on top of layers which are already solidified. They are already solid. So we just add one more layer at a time. So we go from bottom up. In this case, the raw material looks like that. It comes in, plastic spoils. And one advantage is that we can have different colors immediately. So we decide we can make one layer in this color and the other layer in this color. And by the way, the FDA technology is commonly used by a company called Stratasys, which I'll mention later. And this technology, the stereolithography, is used by 3D Systems. It was invented by a guy named Chuck Hull, which was the founder of 3D Systems. He's also responsible not only for the SLA, but also for a file that we all know is the STL file, for good and for bad. This is a little bit different technology. We actually have a bath full of liquid resin, and we have a piston, and we have a laser beam which goes on top, and the laser beam is actually drawing a 2D, making a 2D drawing, and whenever the laser touches, this area becomes solidified. So whenever the laser skips, it stays as liquid. So these are actually layers which are solid, and then the laser hit the surface, the liquid, and whenever the laser touch, it become another solid part, and then the piston goes one step down. And then we repeat again the same process, another 2D drawing, and at the end, we bring it up, and a solid model comes out from the liquid. In this case, the raw material, it comes in, this kind of plastic cartridges. It's in a way similar to the printers that we know. Printers looks very clean and neat. You can have that at home. It's no problem. It's not dirty. It's not toxic. It's really nice. They are coming in different sizes. Now, if we look at the products, we can see some ready-made parts that we can print ourselves. But if we are still looking at mass production, and this is where you start to worry, experts do not see these days 3D printing replacing the conventional technology of mass production. It doesn't make sense. It's not economical. It's good in small series. It's good especially when we need to make products which are actually impossible to manufacture in traditional ways, like this filter, for example. A very interesting phenomena about 3D printing is that complexity doesn't have a cost. In traditional technology, whenever we have a part which is more complex, it will cost more. We are going to work very hard and sweat to make a complex part. There is no cost for complexity in 3D printing. It's free. It's amazing. The two major leaders in 3D printing today, Stratasys, which is an Israeli company, and 3D Systems, which is an American company. And guess what? Cimatron, which is also an Israeli-based company, a Nasdaq-traded company, quite multinational, is going to be acquired, and the closing is expected within the next 2 months by 3D Systems, which is an American company. Metal. The metal printing is very similar to the stereolithography. It's also by laser. It's called selective laser sintering. And here in the bath is the same, and we have the piston, okay? But the difference is that instead of liquid resin, we have metal powder. Now it could be aluminum, it could be titanium, it could be the metal of your choice, okay? And whenever the laser touches, it actually works like kind of a welder. So it hits the particles and weld them together and solidify them. And whenever it doesn't touch, we still have powder. So when the product is done, we just lift it up, we clean the powder, and we have a ready-made part. Yet, the quality, because of the grinding, because of the size of the material, it's not finished, it's not mirror finish. We still have to take it probably to a CNC machine. We still need to do the finishing. Unlike plastic, metal printing is not so easy. It's not straightforward. It's a toxic raw material. We're talking about environmental issues that we need to take care. Machines are expensive, so this is not something that you would like to have at home. You need a special environment, special room in order to have that. It's expensive. But we can get interesting parts. Again, aerospace is one candidate for this kind of metal printing. If you look here at the part, it's very hollow. It's almost impossible again to drill or to find a traditional manufacturing way to do it. But if we print the part, it's very hollow, it will be light, it fits very well to the space, to the aerospace industry. Other examples, this for example is a half jaw of a person. It's an implant. If you want to replace the jaw, those who are, fighting, boxing or Muay Thai, you get hit, you need to replace. So here is it one for you. You print one for yourself, or somebody else will print it for you professionally. This one is a kneecap. It's an implant. Now, you can see the structure, again, is very light and hollow, and the reason is we want the tissues and the bone to grow into the metal, so we have a better bonding of the human organ and the metal. Now again, to manufacture something like that, it's impossible. We print it. It's very simple to print this part, and it uses in the medical industry. Again, a filter. You can see the complexity. So complex parts which are impossible to manufacture in traditional ways. Well, if you go into the craft industry in Thailand or in India, you have these craftsmen that they sit hours and days and they make this kind of art. Maybe they can do something similar, but only maybe. Here it's so easy. The major players in metal printing, X1, AOS, Rainy Show. Recently at the Jimtov exhibition in Japan, a month back, we've seen a Sodic machine, which is a metal printer. It was a hybrid machine in a way that after every layer that we print metal, there is a milling head which clear the surface, do some finishing, and make the particles more smooth, and then put the next layer. Some others are getting into the business as well. If we talk again about hybrid, the one that I mentioned, the Sodic is an example. This one is a hybrid manufacturing machine, not with 3D printing, but it's a DMG machine. We have a milling head on this side. We have a welding head on the other side. And when the milling head is done and removing material, it's called subtractive manufacturing because we are removing material. At the same time, we have the welding head and we can add material. So we have subtractive and additive in the same environment, in the same machine, in one machine. Some other machines are printers and milling. So we see many of them in the future, probably. Now, we print from CAD file to a 3D printer, but it doesn't work because CAD files today are not ready for 3D printers. So the leading software today, if we want to use a printer, would be either Materialize or NetFab. With these softwares, you can do the positioning, you can control the features of the printer. It is there. Let's look a little bit about the mold industry. One example, one way of using 3D printing in the mold industry is for prototyping. We want to make a few parts. We don't want to make a complex mold, you know, we don't want to do it in a CNC machine. We just print the mold and we put it at the core in the cavity. We print the core in the cavity, we put it into the mold base. That's it. And we use it. We can make several, few, 2, 3 parts. Obviously, this mold is not going to stay long because it's plastic itself, so after a few times it's going to bend, it's not going to be accurate, we cannot use it anymore, it's going to melt. But for prototyping, it's good, and it works, and it's fast. Another use is what we call, and it become popular, conformal cooling. We know that we care about the efficiency, we care about the quality of the part, and cooling is very important. If we have an efficient cooling, we can save a second or 2 seconds. It's very important to our profitability. A job could be profitable or non-profitable if the cooling is proper or not, if we can shorten the process. Also, the quality of the plastic in areas which are well cooled are going to be different than other areas. So sometimes we have crazy parts, and this is an example of a crazy part. And, well, how can we create such kind of a crazy cooling in conventional ways? Can we drill it? Of course not. So let's look at a simpler example, easier to understand. This is a small part in a big mold. And we want to do some kind of a spiral cooling like that, and we can't find a catalog part or anything, so we want to do it. Can we drill it? No. What we do is we go and print only this part. Then, of course, we take it, after we print it, we take it to the CNC machine to do some finishing, and from the CNC machine, we use it as an insert in our big mold. So we have just this as an insert for this part. Another example. We usually or typically use baffles and rubbers, but if we take it into a simulation, we can see that in this case, when it gets narrow, it doesn't go all the way up, and the cooling is not even, and we expect some problems in this area. So what we do is we print our own cooling system only for this part, which goes all the way up to the place where we want. We have a much better cooling. We run the analysis. We can see that we're going to get much better cooling. And here we are. Only for this one, we print it. One more example. We have a part here. So typically we use cooling from both sides. Okay? Now, it's much better to use a cooling which goes through the part. If we look at a result, when we use only conventional cooling, we have the part bended. But when we have a conformal cooling which runs inside the part, of course the part looks much better, and this is what we want to do. Now how can we do it? We just print this one, and we are safe. So, what we've seen. We've seen plastic 3D printing for prototypes, for models, prototype for tooling, and in some cases, even production. Same thing we've seen for metal. We've seen prototypes. We've seen some parts for aerospace or medical. We've seen, again, production tooling, what we call conformal cooling, and in some cases we print parts by metal printing, but very limited amounts. Now, where is Cimatron in this business? First of all, in E12, which we are presenting today, we already have what we call conformal cooling design. So if you want to have this kind of design, if you want to go one step farther, many of our customers starting to use it. Customers were using it, but now we have a dedicated function with dedicated module where you can use it. It's very easy, and we export the result into what we call an AMF file, which is added manufacturing format. It's a new format. And why do we use this kind of format and not an STL format? Because this format contains much more information. For example, the color of the printed part, the texture, the material, and many, many other properties of the finished part which you would like to have. So there it is. Future tentative plans for Cimatron. Obviously, we are going to make a much better integration with all 3D printers. This is a plan. We're already working on it. So in fact, our plan is very simple. From a CAD file, you will be able to press print. You will have a dialogue with different machines, and you will be able to print the same way we print today to a 2D printer, to any 3D printer which is in the market. We will not have to use third-party softwares like Materialize or NetFab. We will be able to print directly from any CAD file to 3D printers. Support nesting, support positioning, because you have to understand, it's not just to print the part, you know. Something has to hold the part, and after that we need to cut it. It needs to stand in some way. So we need to have some kind of support to the part. How about if we want to print several parts at the same time? So we need to do the nesting and how to put the positioning in the machine. Everything will be controlled directly from the CAD, so you could do it immediately and fast. Other plans are for mold design. We started to work on variant mold design printed mold modules. So if you want to design some molds which are going to be printed, you will have a dedicated model for that. And of course, with the acquisition, Cimatron becoming a part of this manufacturing world, or 3D manufacturing world, the sky is the limit. We have many, many ideas which are very soon going to be there, and we will present it. It's too early to speak about them, but you might expect a lot of good combination in this world. So it's just one more step towards more efficient manufacturing, something else that you would like to go probably within 5 years. We would look back and say, well, how come we'd never used it before? Here it is. Thank you very much. ขอบคุณครับ สวัสดีครับ